My pedagogical aim for my classroom is to ensure that it is a culturally inclusive place and make it a place where diverse learners can thrive. Through my understanding and reading of the history of mathematics, I can see many ways in which concepts and these notions can be applied to assist in the teaching of mathematics. Take the Egyptians for one. They had a completely different numeral system compared to what we have today. They used the universal notion of counting in the same way with the base 10 system as today, but with symbols instead. Mathematics is not culture for itself, but the notion of counting is. The recording of it can be different depending on the culture. And for students, to understand this is important because yes, every culture can count, but how it was recorded can be different from one culture to another. For example, the Chinese still use a different way to represent their numbers than we do in Australia. Because each child is different, this means that they will not all learn the same. This is the reason that we need a diverse class and a diverse way of teaching. An example of changing methods but also teaching children the correct way can be shown in the following two worksheets. In these worksheets, they learn the same concept of breaking down or building numbers in units, tens, hundreds, etc., but both ways are different and could engage different students differently. There are many theorists that originated from the Greeks, such as Thales and Pythagoras. When teaching students, the steps behind these theories can be challenging. Many of these can be seen as difficult by the students and therefore boring. But our aim as teachers is to get rid of the boring notion and make it interesting. Once a child finds interest in the topic that they are learning, they will then be more than willing to give it a go. As shown in this clip, Pythagoras is being shown in an interesting and fun manner through a video clip. It is important for students to see the reasoning and need behind these mathematical theories, such as Thales and Pythagoras, but that it also doesn't have to be in a boring manner. It can be interesting and fun too. From my readings, I have gained a broad knowledge of the ways in which mathematics is first used. Many of these ways are simplified versions of our current knowledge, and the way in these theorists and concepts came about are very interesting. When teaching students, it is important that mathematics is taught from the beginning. By this, I mean that concepts should be brought right back to the basics, so they can be built and learnt upon to become more complex. Through my readings, I've found many views that mathematics is a boring subject, with no great importance beyond the classroom. This, I believe, is a view that needs to be changed. A way in which I believe that this can be done is not by making mathematics just about numbers and equations on a worksheet, but by bringing mathematics into other areas of everyday activities as much as possible. In this way, students can see the importance and the need of mathematical understanding both in the classroom and outside in their community and daily lives. I believe we should make it as much a part of their lives as possible. Alan Bishop states that one can argue that a mathematical education is no education at all if you do not have anything to contribute to value development. We no longer need this sense of boring mathematics when we teach, can make it an engaging and interesting subject for all students. Before beginning my research, the concept of culture in mathematics to me was absurd, and I could not understand how the link between culture and mathematics could be made. As for anything, not all things work the same for everyone. Mathematics is not automatically understood by all, and not all concepts work with every culture. For example, you might be teaching a group of students that includes some ESL students. They may seem to understand and speak clearly in English very well, but when teaching the mathematics, they may seem confused in the language that is used. This could be because not all words and meanings are translated. An example for this can be in Aboriginal language. To find a word for an enclosed solid is not translatable. They do not have this word in their language, so they cannot translate this into English. The same applies to different theorists. Not all theorems are used everywhere, and there are many different ways in which a solution can be found to a problem. There is no reason that all problems have to be solved in the same way. This is another reason there should be a variety of ways to solve problems provided to students, as not all techniques are understood and work for students for the variety of diverse learners that we have. Achievement in mathematics is not dependent on some immutable quality of a person, such as ability. Rather, mathematic achievement can be expected for all learners with good teaching and the right support.